A good morning, one and all present here. Before we begin with the webinar, I request all the participants to be kindly patient if any technical problems arise during the webinar. We will try to resolve all the technical glitches. Kindly post your questions in the chat box. It will be answered at the end of the session. Please maintain the decorum of the webinar. It's lovely morning and rightly said, you don't have to be great to start, but you have to start to be great. I, Mrs. Karuna Reddy, warmly welcome you for this webinar on Fundamentals of Patents, a popular science lecture organized by Department of Microbiology and Biotechnology at Patkar-Varde College, association with Indian Women Scientists Association. I extend a warm welcome to our guest speaker, Dr. Raj Hirawani sir, a CEO, Dr. Mala Kharkar, a principal, Dr. Shrikant Sawant, Dr. Anthapam ma'am, Dr. Surekha ma'am, Chief Coordinator, Mrs. Ruchita Darvi, departmental staff members, and all our dear participants. Now, I would request Dr. Surekha Jingde, the trustee of IWSA, to address the webinar about popular science lecture series. Surekha ma'am.
Yeah, thank you, Karna. It was nice being here with all of you at Patkar College. I'll
Thank
just
you,
load
ma'am.
my presentation so that we can get moving.
Yes, ma'am. I'll just stop sharing.
Good morning. Good morning to everybody at Patkar College. From IBSA, my colleague trustees, the executive committee members, Dr. Paramjit, who's with me here today. We welcome all the participants for this lecture. We will also acknowledge the presence of the principal of Patkar College and the dignitaries from the Patkar College. And we thank you for giving us this opportunity to be with you and share information about IVSA. And of course, the most important is the lecture by Dr. Hirwani, which is to follow. I take this opportunity to do a quick, brief introduction to the Indian Women Scientists Association, who has ensured that we bring you top science lectures into the colleges for the benefit of the students. Indian Women Scientists Association, we can see this right here at the back, is based in Vashi. The building that you see with the orange dome is the hostel building, and here you see the I think I'll use a different pointer presentation so that it is more. You can see the hostel building. This is an activity center, and here is the green garden that we are so proud about, and the flowers that are blooming at this time. IPSA is registered with the society registration numbers and the Bombay Public Trust, and we also have a Niti Aayog unique ID, and we have been at IBSA for a long number of years. IBSA has completed 47 years, and this June we will complete 48. It was registered way back in 1973 by 12 scientists who believed that science should not remain within the walls of the laboratory but should move outside, and it should be science for society. And with that aim, you can see that we have started 11 branches across the country, right, with Roorkee in 1979 in the north and Nellore and Bangalore in the south. They are the more recent branches which have initiated. So these are 11 branches across the country, the headquarters being at Vashi, and we have about 2,300 IBSA members. Our main mandates are taking science to society and women empowerment. And the two arms of our activities are community welfare and science awareness. And during 2019-20, we have reached out to about 23,000 recipients, and this year it's going to be many, many more. Among the community welfare activities, we have a working women's hostel, a healthcare center, a computer center, a library. Then we have the daycare center, nursery school, an ECC program, and scholarship awards. The Working Women's Hostel has position for 160 women who earn anywhere between 10,000 rupees to 50,000 rupees. and it is working under the guidelines of the Ministry of Women and Child Development. It has been open right through these COVID times, and though the occupancy was less, yes, we were working. I think it's one of the few hostels which are open in this in Mumbai. The healthcare center has positions for a dentist, a clinician, and a physiotherapist. We have restarted our activities this month after the block with COVID. A computer center which has positions for teaching computers right from daycare children or little children in schools up to senior citizens. So this activity is going on very slowly at the moment. The library is funded by the Maharashtra State Library government, and we have started this about 2 months back. We have a large number of girls who come there and utilize the quiet space for studying, in addition to using the books, which are about 5,000 odd books, which are there of relevance to their requirement. Then we have scholarship awards, which are given to students from 10th, 12th standard, BSc, MSc, and PhD. These are awards from interest earned from the money received from donations of well wishers, and these are advertised every year and sent to the colleges to ensure that the students who are eligible for these scholarships get them. They are one time awards, but they help students to buy their books and whatever necessary for their studies. The daycare center has position for 36 children from age of 6 months up to 13 years for girl and 10 years for boys. It's open from 7:30 to 7:30, but now over the last year we had to remain closed, and we're waiting for a signal to start that again. The nursery school is for children who are about 2.5, 3 years to 4.5 years. And this major program, the Early Childhood Care and Education program, is a 1-year diploma in early childhood care and education. It is under the SNDT Women's University, and girls who are 12th standard pass, age no bar, can apply for it, and they would at the end of it get a diploma from the SNDT Women's University. This is a very important course, especially those who want to teach daycare and nursery school. And today you know that early childhood care and education is receiving a major importance in the national education policy. And this course will now again begin in June, July. It is already ongoing for the previous batch, but those who wish to apply for it can apply for it now. It's an online course for the present. And in addition to this, we also have 2 short-term courses, which are 1 month and 3 months, to understand the attention deficit the disorders of little children and learning deficiencies of the children, and shadow teacher training, which is being conducted along with Drishti, which is another NGO, which is very strong in these kind of programs. And ECC actually celebrates 25 years this year. So it's not a new program for us. It's a very ongoing program, and we have continued over the COVID times. Now, we have science education initiatives for school students. We have a very small science laboratory, which you can see here. And our volunteers, ladies, lot of them come forward. Here they're showing them some experiments within that. They also teach young students from neighboring schools who need attention after their school hours, and they are from the community which requires assistance. And here you can see bright young faces. Boys and girls come here after school hours, and our teachers teach them physics, chemistry, maths, and biology, and also sometimes English and computer science, computer handling computers. We have science lectures, we have science camps. You can see here is a camp going on, and here is an exhibition going on. So it's a very popular activity and very, very active activity which is ongoing. For college students, we have the popular science lectures, and which you are attending one now. The lecture workshops for science academy support, and refresher courses are for faculty, and the lecture workshops are for students and faculty, which is from the 3 science academies. These have held once in a year. We also have very major initiative of the learning garden. Here we have lot of plants growing in IBSA. We have visitors who come and see them, and you can see some representatives of them here. And more than that, through the green initiatives and the learning garden in particular, we have been able to reach out to colleges who have been coming to us for making projects. And recently, we've had a very major initiative from the SIES Management School where young students have taken on projects in relation to the learning garden. So I would request all of you to consider visiting us and seeing the learning garden when it is possible. We also hold, of course, the Republic Day. We had this year Mrs. Jagannathan, who is a Padma Bhushan. She shared her experience in improving the livelihood of women and ensuring they got free land, and it was really moving to hear her talk about her efforts to do this. On Science Day, our volunteers have put together extremely interesting programs, and they were having children from the 7th to the 11th standard show working models of science-based experiments, made presentations of scientists, and they also made some computer apps. It was a very interesting science day for the youngsters. We have webinars for our IBSA members on a variety of topics, and they range from mushrooms to orchids and to bonsai. And now we're going to have one today, in fact, in the evening on forgotten foods. And there are many, many lectures which still keep coming. As I mentioned, COVID has not stopped IBSA. We have been conducting popular science lectures. We used to go to the colleges, as you see, or the audience sitting here. Even in the branches, we have gone across. And during the financial year 1920, we reached out to nearly 3,800 odd students. We take lectures in physics, chemistry, biology, and engineering. Speakers are from very renowned academic institutes, and we have moved to even our branches. And this year, we are really moving to our branches in force because of the virtual possibilities. Last week we had lectures in Nagpur, Cochin, Mumbai, of course. This is our 47th lecture this year, though we started only in July 20, and we have reached and probably counting outreach to about 3,000 right here. So, popular science lectures, we are able to bring to you very interesting topics, even visits to the Antarctic, space exploration, looking at the cells under the microscope, power from thorium, what are the problems with food safety. And today we are going to hear Dr. Hirawani on about patents, and I think many of the microbiology and biotechnology students are definitely going to benefit from the same. We have another one which is for society at large. We call it Science and Our Life series. We'll be coming up with our 11th talk this on the 13th. That will be on how to protect your liver. But we've had talks on organ donation, aerospace journey by Dr. Tessie Thomas. We've heard about stress and how it affects our life by Dr. Vidita Vaidya, and many such lectures will continue. We have a newsletter which captures all the activities that we do, right from the 11 branches and at headquarters. And those of you who are interested to know what we are doing, do go up to the website and download the newsletter, and you will get the details of the activities. So do join us as a member. Here you will see the little children in their daycare when it's active, in the nursery, the ECC girls teaching playway method. This is the cafeteria of the hostel. This is the library when it was full, and now what is the situation? We run health camps, which you can see here, doctors with the Indian Cancer Society. We have the computer room, and here the scholarship programs. One of the girls is getting a scholarship award. Our programs are supported through donations and government grants for specific projects. Do help us in our endeavors to help others. You can contact us at ivsa_headquarters@gmail.com or at ivsa.net. Get more information And if you want any specifics, send us a mail. We'll be very happy to write back to you, and do consider joining as a member. Before I close my talk, I'd like to thank everybody from Patkar College, and in particular Anupama, Dr. Karuna, the principal of the college, for permitting us to hold this lecture through your premises, and Dr. Hirawani for being with us here today, and the audience. Without you, we would not be here. Thank you so much for being with us. God bless you all.
Yeah. Thank you, ma'am. Thank you, Surekha, ma'am. Yeah, now I would like to introduce our today's speaker, Dr. Raj Hirawani, sir. Sir has 40 years of techno-commercial experience in research and industry and holds a PhD in technology management from IIT Mumbai. He is a Fulbright scholar and was a recipient of Herbert Humphrey Fellowship Management from IIT Mumbai. His focus is on IP management in academic and publicly funded in technology policy management. Uh, Till recently, he was the head of Intellectual Property Directorate in CSIR and director of a CSIRS unit for research and development. Sir has been actively involved in value-added informatics activities. Sir has pioneered the patent analytics services in country. He created for the rest time in the publicly funded system and R&D service unit that recovers its full revenue budget by providing services to the external clients. Before this, he was head of research planning and business development division at the external clients. Before this, he was head of research planning business development division at the National Chemical Laboratory, Pune, where he was involved with the pre-research appraisal and the techno-economical evaluation of the projects, IPR management, technology transfer, and business development. Sir has a coordinated World Bank funded Technology Institution Support Services Program at NCL. He was a member of World Bank consultancy team for strengthening of R&D institutions in China and Indonesia. He has won many national awards and honors. He is only member of number of CSIR and government committees. He has held numerous positions in the academic institutions, including the member of Senate and Academic Council, adjunct professorship, and is recognized PhD guide. He is a president of Licensing Executive Society India. He has traveled world over in a number of countries on the official assignments and addressed international audience at WIPO, Geneva, Washington, USA, Fukuoka, and Japan. It is an honor to have such an eminent personality with you today. Sir, I now request you to begin the session. I would request Dr. Raj Hirwani, sir, to address the webinar. Thank you.
Thank you, Dr. Karuna, for that kind introduction. At the outset, I'd like to thank Dr. Zingle for inviting me to share my thoughts with you. I actually admire Dr. Zingle and her colleagues for starting Indian Women Scientists Association. They are doing a selfless service in the interest of the science and society. My compliments to all of them. And also thank Patkar College, Professor Samant, and all his colleagues for participation in today's event. Dr. Single requested me to speak on patterns. So I will just share my presentation. Are you able to see the slides?
Yes. Yeah.
Okay.
Yes, we can now.
Thank you. Normally, I give this lecture for about 3 hours, but today I'll try to squeeze in about 50 to 60 minutes. So when we are talking about patents, we're basically talking about a subset of intellectual property rights. Now, what do we understand by intellectual property? Different people have different concepts and notions about it. Basically, we should go back to the concept of property. When we say, this is my property, this house is my property, this car is my property, what we are basically saying, I own it. And I'm free to use it as I want. And I can exclude others from using it. I have a house, I'm not living into it, I kept it locked. I don't want to give it to anybody else to live it on rent or anything. So the exclusion is an important part of that right. So when we talk about intellectual property, is a type of property that results from creation of human mind, the intellect. As simple as that. The concept of property applied to creation of human mind. Is there an official definition of intellectual property? Answer is no. World Intellectual Property Organization, which is a UN body, when they were established, let us see what was written in their convention. It says literary, artistic, and scientific works, performance of performing artists, phonograms and broadcasts, because at that time technology was still not digital, inventions in all fields of human endeavor, scientific discoveries, industrial designs, trademarks, service marks, and commercial names and designations, protection against unfair competition, and all other rights resulting from intellectual activity in the industrial, scientific, literary, or artistic fields. So it is a wide canvas. So intellectual property rights today are bundled into different categories. One is literary, artistic, and scientific works, that is books, articles, poetry, novels, dramas. So this is governed by copyright laws. Then is performance, broadcasts. Gulzar writes a lyric and he gets a copyright. Lata Mangeshkar sings. She brings that performance to public. So while Gulzar gets a copyright for his song, Lata Mangeshkar gets what is called a performance right. You write a drama, some people come to the stage and perform. For what you have written, you'll get a copyright, but people who are performing on the stage get a performance right. Now, since Lata Mangeshkar's performance right is linked to Gulzar's copyright, it is also called related rights. Then you have inventions, a new drug for tuberculosis, or maybe a new drug for COVID, a new form of a jet engine. All these inventions are covered by laws concerning patents, and that is the focus of our lecture today. Then you have industrial designs, a shape of a say soft drink bottle, a Coca-Cola, those ridges, a styling of a car or a scooter. All these features which appeal to the eye for the aesthetic purposes, they get covered by industrial design. Then you have trademarks, Bata, Nike, Reebok. Basically, they represent footwear, but they are used to distinguish products of one manufacturer from another. They get covered by trademark. Service mark is nothing but a trademark applied to a service. India Post has a courier service called Speed Post. So Speed Post becomes a service mark. Then there's a relatively new form of intellectual property right, which are geographical indicators. It relates to products with certain unique geographical origin and properties which are due to a certain agroclimatic condition in those regions. So when you say a champagne, it is a wine made by grapes grown in Bordeaux region of France and part of Germany. When you say Darjeeling tea grown in Darjeeling district of Assam, basmati rice grown in certain parts of India and Pakistan. So that unique property, the flavor, comes from the agroclimatic condition there. Then all of us have electronic devices, whether our mobile phone, laptop, etc. And they have those electronic circuitry that get protected by a separate international treaty on integrated circuits. There are new plant varieties, done breeding programs in agriculture universities, they covered by Plant Varieties Protection Act. And finally, all the confidential information which is not in public domain and not covered by any of those intellectual property laws can be protected as a trade secret. Now, with this brief introduction of different IP rights, let us get down to the patents. Now, what is a patent? We say I have a patent, and people think once they have patent, they have monopoly, they can do whatever they want to do it. Legally, that is not the case. It is a right granted to inventors to prevent unauthorized use of invention within a particular territory for a limited time. It does not guarantee the freedom to exploit the invention. Nowhere it says you can do whatever you want to do with your invention. All it does is enables you to stop others from using your invention within a particular territory and only for a limited time. You're not getting a right to automatically exploit your invention and reap the benefits. Now, I have put certain words in bold. Prevent, particular territory, limited time, freedom to exploit. Now, let me explain all this to you. It is a negative right. It is giving you a right to stop others. It is not giving you a right to do anything positively. So, it is a negative right. Who is giving you the right? The right is granted by the government. Now, Government of India cannot give you a right which you go and exercise in the United States. US government cannot give you a right which you go and exercise in Japan. So any right given by any government gets restricted to its own geographical boundaries. So when you have an Indian patent, it is restricted to geographical boundaries of India. An Indian patent has no force in other countries, just as foreign patent has no force in this country. So if you want to protect your invention outside India, you have to go and apply and get the patent in those territories. A lot of small medium enterprises come up, so this is a US patent. I say, look, they do not have corresponding patent in India. So you are free to use this invention in India without bothering, without paying them any royalties. But ensure that you do not export this product to the United States. Because the moment it lands in US, you will be infringing their patent. Again, this right to exclude others has a time limitation. It is 20 years from the date of application. So today on 10th March 2021, if you apply for a patent and if it is granted, your right will expire on 9th March 2041. After that, it is free for anyone to use this. The time used to vary from country to country. Under the harmonization which has been done in 1985 is 20 years across the world. Now let us come to the most important part. Why you do not have an automatic right to exploit your invention. You have got a patent in certain technology or product area. It is possible that others have got the patents in the same technology and product area before you. The way you got the right to exclude others, In their others, you are included. So your positive rights get restricted by those previous patents. This becomes confusing. So I always like to give an example of a light bulb. If I ask a question, who invented the light bulb? Excuse me. I give the answer, Thomas Edison. Thomas Edison did not invent the light bulb. 10 years before he brought the bulb to the market, a gentleman called Henry Woodward conceptualized the light bulb, invented it, got the patent. The disadvantage of his invention was that filament used to get burnt away in few minutes. If your filament goes off in few minutes, you can't have a commercial product. But once the patent document was published, people looked at it and said, what a great idea it is. The lighting industry. So people started working on different materials, different processes. While doing that, they got the patents. Finally, Edison succeeded having a tungsten filament which lasted for 1500 hours and got the patent. Now, since filament lasted for 1500 hours, it was not possible to make a commercial product. Now, Edison has the patent. Can he go and make the light bulb? Answer is no. Light bulb as a product was conceptualized and invented by Henry Woodward. Thomas Edison's invention is in a tungsten filament. So he cannot make the light bulb. He gets restricted by Henry Woodward's patents. So Henry Woodward can stop him. Because Henry Woodward has a right to stop others from infringing his patent. So Thomas Edison, by making a light bulb, is going to infringe his patent. In such a situation, there are only two possibilities. Edison goes and takes a license from Henry Woodward, or Henry Woodward takes a license from Edison and incorporates tungsten filament into his bulb. Thomas Edison went and took a license and then commercialized the light bulb. Since he was the person who brought the bulb to the market, his name got associated with the bulb. Henry Woodward never came to the market, so nobody knows about it. But this is called freedom to operate, freedom to market, freedom to practice. Thomas Edison did not have freedom to operate. Freedom to practice his invention. And this is a very, very important part of the patenting system which people don't recognize, realize. You may have a patent, but you may not have freedom to operate. You need to ensure that you are not infringing anybody else's patent. Then only your negative right can turn into a positive right. So every time patents are licensed, or even your own patents are practiced, this exercise is undertaken by every company. And another important point I wish to inform you, all patent documents are published after 18 months from the date of application, irrespective of whether you are granted the patent or you are not granted the patent. If your patent is granted, your protection starts retrospectively from the date you applied. If the patent is not granted, all that information is in public domain and anybody can use it. So the question is, why this is done? See, society for the development requires a new knowledge. For development to take place, new knowledge must come into the public domain. And knowledge is built brick by brick. Even when you're doing a PhD, you join a professor. So some other students has finished a PhD, brought the work to a certain level, the professor assigns the work to you, you carry it further, bring it to a particular level, the next student will come, he'll take it further. Now, society wants a new knowledge for development to take place. As an inventor, we have vested interest. We invested time, money, energy to generate that knowledge. So we want to maximize return to ourselves. Because that we don't want to put it into public domain. So there are now conflicting demands on new knowledge. Society wants for development and we want it for personal benefit. So patenting system has been created as a kind of a balancing act between the public interest and the private interest. So patents are granted in return for your full disclosure on the technology to the public. So when you write a patent specification, you are basically making a disclosure and that document is going to become public. In return, the society, the government, gives you a right to prevent anybody else from practicing their invention for commercial purpose for their limited period. So you are expected to maximize your returns in those 20 years. And after that, the invention is free from anybody to use it without paying any royalties to you. So once the knowledge becomes public, the development can go on. If Henry Woodward's invention was not in the public domain, there would not have been Edison. There would not have been a light bulb. So you go into the history of any product development, any technology development. Somebody started, got the patent, other people kept on adding. It took quite a while before it became full-blown technology, optimized product. That is how the development goes on. So remember, patent is a social contract between the inventor and the society. The system has not been created to make monopolies, but to bring new knowledge to the public domain. That is a prime reason for the patenting system. Now, why do these rights matter? Well, obviously, it creates an incentive towards the creative endurance of inventors. It gives creators an official recognition. As a scientist, as a technocrat, our satisfaction, our emotional state rises. We get an official recognition. The psychic income is more than the monetary income which we get. When I say I have 30 patents to my credit, I have respect. And because these documents become public, it creates a repository of vital information. Already more than 130 million patent documents are in public. You can see them on the web, sitting anywhere in the world. This facilitates the growth of domestic industry and also promotes international trade because IP is today part of the international trade documents like WTO and so on, that agreement. So now let us look at it. What are the requirements of patentability? You have done some invention, and you want to know whether it's patentable or not. There are two types of requirement: substantial requirement and procedural requirement. Substantial requirement is subject matter, novelty, non-obviousness, and utility. Procedural requirement are enablement, definiteness, and base mode. I'll explain each of those terms. But before I proceed, let me make it very clear. Ideas and concepts cannot be patented. Very often we say, I have an idea, I want to take a patent. You can't take a patent on an idea. You have to show that your idea works. So minimum amount of experimentation to show that idea works is sufficient. You may do reaction on a few milligram level. You may build a very crude prototype. Nobody is expecting a finished product. A crude prototype, it just shows that your idea is working. Is enough. Now let us look at those requirements. When I say subject matter, invention is about what? A method of manufacture? Is a machine, device, apparatus? Is it a composition of matter? An alloy is a composition of matter. A catalyst is a composition of matter. Process. It may be a chemical process, it may be a metallurgical process, it may be a biotechnological process. So it has to be about one of these. Utility. Your invention must have some use, some application. I'm a chemist. I cannot just go to patent office and say, here's a new molecule I have synthesized. Nobody has synthesized this before. Now give me a patent. I have to show what the new molecule does. Is it a drug? Is it a pesticide? Is it a food color? Is it a cosmetic additive? What it is? It has to have some utility. Long time ago, when human genome was being decoded, the company which was working went and filed thousands of applications on different genes. Patent office rejected all of those, saying what does that each gene does? What is the function? You can't just ask for a patent. You must show us what does each gene is doing. Then comes important aspect of novelty. Novelty is something new under the legal requirements. It should not be anticipated in prior art. What is prior art? Anything which has been previously published in a book, in a journal, newspaper, whatever it is. If not published, should not have been patented. The other people might have patented, but they may not have published in the books, journals. It is not published, it is not patented, but it is already known. Why are we saying this is traditional knowledge? For a generation, we have been using it. It is already in use. It is already being sold in the market. Nobody has published this, nobody has patented it. So it is in public domain. So all this is a part of prior art. So your invention should not have been anticipated by prior art. Then is another important consideration called non-obviousness. So what is obviousness? Knowledge at the time of invention must not be obvious to one of the ordinary skill in that area. Again, I am a chemist. You come and tell me that you have synthesized vinyl stearate. I say, yes, you have taken vinyl alcohol, you have taken stearic acid, you have taken few drops of sulfuric acid as a catalyst, and you made this an ester. I am a biologist. Somebody comes and tells me I had in solid state fermentation. I know what he's done. I bring some metallic product, keep in front of you. You are a metallurgist. As soon as you look at it, you say you have done sintering. So what all three of us are doing? We are skilled in that art. So it is obvious to us what you have done it. So the invention which you have done should not be obvious to a person who is skilled in the art. 99% of time, we do an invention which is novel. Nobody has done it before. But that is obvious to a person skilled in the art. So your patent application must pass this non-obviousness test. This is the most important part of the patenting process. And majority of patenting applications fail on this count. And this is a dynamic concept, not a static, because it is determined by the scope and content of the prior art. As the level of technology increases, so does the obviousness of advances. See, 40 years ago, none of us knew that you can cut the genes and join them, gene splicing. But today, by using restriction enzymes, you teach students at undergraduate level how to cut the genes. So 40 years ago, it was non-obvious. Patents were granted. But today, you go to a patent office, they will reject it because the ordinary skill has increased. It is obvious to even students. So this will keep on happening as the technology keeps on moving. Today we are talking about gene editing. Now, gene editing 3 years back was not there till CRISPR came. But now it has become obvious that you use the CRISPR. Then let us come to requirement of procedural requirement. One is enablement. See, we said the purpose of patent is to make the knowledge public domain so that development can take place. So whatever you are disclosing in your specification, it should enable anybody else to reproduce your invention without undue experimentation. If I am working in an area and I want to do a further development, I should be able to reproduce your invention. I don't want to do hundreds of experiments to arrive at the right optimum condition. Second is definiteness. You are asking for a protection of your invention. That invention must have definite boundaries. See, when you buy a land, you have an agreement. At the end of that agreement, there's an annexure, which has a diagram of that plot. So it is a rectangular plot, plot number 61. Both the dimension, length and breadth are given. Then it says on the right hand side is a plot number 62, on the left hand side is plot number 60. Back side is a plot number 51, and there's a front, there's a road. So it defines the limits of your plot. There are definite boundaries of your plot. You never say, my land is till your eyesight goes. So if I'm a chemist and I synthesize a molecule, I can't draw just a benzene ring and put R1, R2, R3, or 4 or 5 and say carbon atoms 1 to infinity. It can be endless possibility. So I can say where R is 1 to 6, 1 to 8. So there are limited permutation combination possible. So that is the limitation of your claim. You can't claim anything on the earth. Even in a particular product area, when Edison is writing a patent, he will say tungsten filament. And third is the best way to carry out your invention must be disclosed. If I do a reaction at 60 degrees and I get a yield of 70%, and I raise the temperature to 75 degrees and I get a 90% yield, the best way is the latter one. So I'm supposed to disclose the best way. If I don't do it, there are two possibilities. Sooner or later, somebody will discover that if you raise the temperature, you get a higher yield. He can go and apply for a patent and he will get it because I did not disclose. His invention is a superior one. My invention loses the value. And if it is found that I have concealed this information, my patent is held invalid. So these are the main requirements of patentability. Now assume you meet all these requirements of patentability. Under the law, there are still limitations, where even if you meet these requirements of patentability based on the patent document, there are certain exceptions because of which you cannot get the patent. Let us look at them. An invention which is frivolous or which claims anything obviously contrary to the well-established natural laws. You can't get a patent on perpetual motion machine. This ideal condition doesn't exist. In invention, the primary or intended use or a commercial expression of which would be contrary to public order or a morality, which causes serious prejudice to human, animal, or plant life, environment, etc. You can't say I have a microbe which is going to do bioterrorism. Recently, Patent Office in India rejected a patent for a sexual toy, saying it's against public morality. The mere discovery of a scientific principle or the formulation of abstract theory or a discovery of any living thing or non-living thing in nature. Newton's laws of gravity, Einstein's theory of relativity cannot be patented. They are discoveries. The difference between discoveries and inventions. You go on an expedition to Himalayas, discover a particular plant. It's a living thing in nature. You can patent it. Reliance is doing exploration in Candy Basin. They find natural gas. There's a non-living thing in nature. They can just go and patent it. The mere discovery of a new property or a new use for a known substance or the mere use of a known process, machine or apparatus, unless such known process runs a new product or imply a new react. This is Indian addition to patent law. It's called Section 3D. Nowhere else in the world this provision exists. There's a reason for this. Pharma industry does a research, and very often the particular molecule has applicability in more than one therapeutic areas. And patents expire. Out of 20 years of patent, very often 8 years go away in doing toxicological trials, clinical trials, and so on, before the drug is approved for a commercial use, public use. You may get a patent, but you can't sell the drug unless you have gone through regulatory requirements. Regulatory requirement ends 7 and 8 years. Your life is only 12 years. So pharma companies find ways and means so that they are able to establish monopolies. So initially, you come with, say, amlodipine. As a chemist, you know many of the chemicals have racemic forms, D and L. So the first patent will say DL amlodipine. 5 years down the line, you said is D amlodipine, which is active. AL is not. Actually, AL is causing some side effect. So your next patent says D amlodipine. 4 years down the line, you say beta crystalline pharma amlodipine is actually antihypertensive. Further down the line, now you say beta amlodipine is also anti-cancer compound. So each of your patent has a 20-year life. This is called evergreening of patents. Government of India said, we are not going to permit evergreening of patents. Therefore, this clause was put. The mere discovery of a new property or a new use for a known substance will not be patented. Worldwide pharmaceutical industries against this provision, they are upset with us. Every time an Indian Prime Minister meets the US President, this item is on the agenda, that it should be removed. But we are stuck to our guns. The next is a substance obtained by the mere admixture, resulting only in the aggregation of the properties of the components or a process of producing such substances. You take A, which is a property of X, you take B and a property of Y. A plus B gives you X plus Y. You can get a patent. It is just an aggregation. But you do A plus B and you get the result Z, then you can patent because Z is different from X plus Y. The mere arrangement or rearrangement or duplication of known devices, each functioning independently of one another in a known way. I have a transistor, I have a clock. I put both of them in one box and try to get a patent. I can't. Now, if I connect transistor to a clock in a manner that as soon as clock strikes 6, the transistor starts. Now I can get a patent. Because no longer they are functioning independently. There is a dependency. When clock is striking 6, transistor is starting. A method of agriculture, horticulture. In agrarian society, we want all these inventions to be freely available to the farming community. So we don't want to give patent. A process for the medical, surgical, curative, prophylactic, diagnostic, therapeutic, or other treatment of human beings. Any process of similar treatment of animal, plant to render them disease free. Dr. Devi Shetty finds a way on our heart surgery, he can't get a patent. In the interest of the healthcare of the population, we don't want to grant him a patent. There's a famous case of an ophthalmologist called Paul Singer in the United States. He found a new method of cataract removal and patented it. And then started enforcing his patents against all the ophthalmologists who were practicing. Matter went to US Congress. They realized it's the wrong thing to do. Now, US is the only country where patent is part of their constitution. So for them it is very sacred. So they did not remove that. What they did, the Congress passed saying one doctor cannot enforce his patent against another doctor for practicing. So basically nullifying that right. So you can still go and get a patent in the United States on a surgical procedure, but you can't enforce it. But in our law, we are clearly saying we will not grant it. Plants, animals in whole are part thereof other than microorganism. Till the GATT happened, even we had excluded microorganisms. But now biotechnology is advanced, fermentation science is advanced, there are a lot of commercial products applications, so microorganisms today are patentable. A mathematical or business method or a computer program per se are algorithms. US government grants your software patents. We don't grant. In India, a software patent is a literary work, so you'll get a copyright but not the patents. What is a business method? If I give you a simple example, you'll laugh. You go to a shopping mall, buy two, one is free. This is a business method. So US has such ridiculous patents, but we have made clear that we will not. Literally, dramatic, musical, artistic work or any artistic creation. So all this part of copyright, but we again made it very explicit on patent law that we will not grant a patent. Be a scheme or a rule or a method of performing mental act or method of playing games. Your scientific calculate, you can't get a patent because the number system is a performing a mental act. Presentation of information, topography of integrated circuit, I told you there is a separate provision for that. Invention, which effect is a traditional knowledge or which is an aggregation or duplication known property of traditional. This is again an Indian addition to law because when we found a lot of our traditional knowledge was getting pirated and patented abroad, we made it clear in our law that any invention which is a traditional knowledge or which is an aggregation or a duplication of known properties or it has any component of traditional knowledge, we will not grant the patents. Now let me bring to an important concept of a product patent and a process patent. Let us assume X is a product, a pharmaceutical product, a drug, which is made by two raw materials, capital A and capital B, using a process denoted by small a. So let us say Glaxo has patented this. So Glaxo gets three patents, three rights. Patent on X as a product. Patent on the small a as a process. And a patent claim on the use of X as an anti-ulcer compounds. Now when you get these three claims, your X is protected. So nobody can make X, nobody can use a process A, and nobody can sell X for an application as an anti-ulcer compound. This is what gives pharmaceutical industry a monopoly. Worldwide, they file patents for their invention, and nobody can make that X. But way back in 1970, when we were early part of our journey as an independent nation, we didn't have money to import, we didn't have industry to make. We had changed our, I'll not get into the history because I have limited time. So we had made change in our Patent Act, saying we will not grant product patents for pharmaceutical, agrochemicals, and food products, which means X will not be protected as a product. You'll only get a process patent, which means small a will protect it. When that happened, our Indian pharma industry got a chance to develop alternative processes. So let us say Randburg C will start with B plus C with a new process called small b and make that X. Market is big so that people will get into it. Dr. Reddy will take B plus D, develop new process small c. Cadila will do C plus D with a small process D. And this will go on till they reach the limits conversions. This is what gave the capability to Indian pharmaceutical industry. Process capability is unparalleled in the world. Worldwide, pharma people get that product patent, so nobody can touch it. So nobody bothers about the processes. The main inventor, his whole attention shifts to getting into the market fastest to maximize the returns. And nobody touches X because you can't. But this was the only country which permitted by not giving product patents to X. That is the reason we have pharma industry thriving in the generic industry, which produces cheapest drugs in the world and it's called pharmacy of the world. But under the GATT agreement, we went back and we made the laws change. So product patents were introduced back in 2005. So patents to the products capable of being used as a food, agrochemical drug and also the chemical processes. And chemical process were expanded to include biochemical, biotechnological, and microbiological processes because life science industry has made tremendous progress and a lot of products are commercial. So let us look at this aspect in the life science industry. So I'm using generic term biotechnology. I know the life scientists don't like this word. For them, biochemistry, microbiology, all are different branches. But just for the sake of this discussion, let me use the generic term. So biotechnology is basically any technological application that uses biological systems, living organisms, or derivatives to make or modify products or processes for a specific use. So you have commercially useful products with impact in food, drug, antibiotics, industrial products, ecology, green processes, and so on, with their tremendous benefits. Now, patent legislation prohibits protection and mentions specifically in following fields. For the reproductive cloning of human beings, process for modifying the germline or genetic identity of human beings. In other words, you cannot enable genetic modification to be passed on by parents or their children. Otherwise, people will start ordering designer babies. Use of human embryos for industrial or commercial purposes. Or processing for modifying the genetic identity of animals which are likely to cause them suffering without any substantial medical benefit in terms of research, prevention, diagnosis. So what can be patented? Microorganisms can be patented. Genes, especially the synthetic one, can be patented. Genomes, plasmid, ASTs, recombinant DNA, monoclonal antibodies, gene therapies, cell therapy. The famous case of a company called Marad Genetics. They were granted a patent on a BRCA1 gene, which is associated with breast cancers. After that patent was granted, a lot of people filed patents on important inventions, including genetic tests related to BRCA gene. And this Marad Genetics started suing each of the medical university, each of pathology laboratory for doing the testing. They went so aggressive that all the medical famous places, Harvard, Mayo Clinic, or whatever, everybody stopped doing testing. And people went to the court recently after this is 1993 patent. So then Supreme Court reversed the decision. They had held the gene patent which was granted to be valid. Then they said human genes cannot be patented, but complementary DNA, which is synthetically created from gene material, is patentable. Now let us come that you have the patent, but there are few things which as a researchers you should be aware. Because all of us in academics take certain actions for granted and don't bother about them. And those communications count against us. We have propensity to publish. We want to be the first. We want to rush to the publications. A publication destroys novelty because it says should not be prior art. Prior art is anything which is published. When we say published, it's not only a printed publication. Slides. I'm giving a presentation. You go to a scientific conference and make a presentation. You go to IEEE as an engineer, institution of engineers, you make a presentation. There's an exhibition. You have a stall. You put a photographs. You put a working model. You can give a speeches. Indian Medical Association or Association of Microbiologists. We distribute brochures. We have PhD thesis which gets lodged in the institutional library, a university library. The moment it comes in the library, it is catalogued, it is available for anybody to refer. So that is a public disclosure. So all this constitutes your research being in public domain. Very often government research grant proposals. Under the Information Act, I can ask for copies. At least in India, nobody has done it, but under the US law, it can be made available. People have gone to the court and said, sir, it is on my own paper. Sir, it was our own company stall where we showed. Sir, it was my own thesis. Court says, why did you do it? You did it because you wanted to make it accessible and you wanted to disseminate the information to others. By your own voluntary work, if you have done it, action, you can't come back to us and ask for the protection. So if you are intending to take a patent, please do not publish, do not take any of these actions to make your knowledge public. You don't have to wait for the patent to be granted. Just filing an application is sufficient. Application filing gives you the date, what is called priority date. So the moment you have the priority date, that becomes a date on which you ask for the protection. So anything which comes after that becomes a part of prior art. So your own work is prior art now. So if you publish, then it's fine because you have filed a patent. Making invention available on sale. Very often people don't think. They come to the market, they succeed, other people start copying, then they realize and then go for file a patent. But putting an invention on sale or a public use basically comes against you. US is the only country which gives you a luxury where you get a 1-year grace to file a patent after your publication. After you've made the knowledge public, you still have 1 year time to get a patent. If the biotechnology industry exists today, it exists just because of this provision in US law. The famous discovery of Bayer and Cohen on gene splicing was published. Both of them had met at a conference and decided to work together. They published this work, and one of the science journalists read that and wrote an article saying, what a great invention this is, and it realized the life science industry. The Stanford University chancellor read this and asked his technology transfer office, have we filed a patent? The head of that office said, sir, nobody has filed a disclosure. We are not even aware of this. He went to a professor and said, sir, we can still file a patent. He said, I'm not interested. I like to publish my work. He went to the neighboring fellow, his co-worker, said, "Sir, I'd like to file a patent," and that fellow agreed. He came back to his professor and said, "Sir, he has agreed. Why don't you agree?" Out of the respect for that his co-worker, his co-professor, he agreed. They filed for the patent. It's a seminal patent. Stanford University had 430 licenses of their patent because anybody who wanted to work in that field had to take a license. They minted millions and millions of dollars out of that patent and that patent expired. So biotechnology industry survived just because of this. But remember, they lost that invention to the rest of the world. They couldn't protect it anywhere else because no other law gives you that provision. Now, who qualifies as an inventor? Legally, person who conceives the idea is the inventor. If you are a student and if your professor has given you an idea and say perform an experiment, if you succeed, you are not the inventor. You did not conceive that idea. What you did is called reduction to practice. You reduce that idea to practice. Reduction to practice is not the inventorship. So you cannot claim the inventorship. But assume as a student you have an idea, you go to a professor and say, "Sir, I have an idea, I want to try." The professor says, "Go ahead." If you succeed, you are the inventor, your professor is not the inventor. Because professor did not conceive it, you conceived it. So professor cannot claim the inventorship. But assume you fail and go back to the professor, and professor looks at your data and realizes where you have made a mistake and what can be done. And he gives you suggestions which you incorporate and then you succeed. Now professor can claim co-inventorship because he made conceptual contribution to that. In my career of 40 years, I have seen maximum fights taking place on this aspect. I was an inventor, I was a part of the team, but my name is not there. Just because you are part of the team does not entitle you to be an inventorship. What did you contribute conceptual level to that invention? Again, I have stories to tell, but so that some other time of this, fights. But remember, if you have not done any conceptual contribution, if you've just done some experimentation, you're part of the team, you've done some analytical work or anything physically just work, you cannot be on the inventor list. You are the inventor, are you the owner? See, if you have been hired to do research, the well accepted principle, person who hires you becomes the owner. I am employee of CSIR. I am doing invention. I will be inventor. I will be listed as inventor, but CSIR will be the owner. You are employee of IIT Bombay. You will be inventor. IIT Bombay will be the owner. You are employee of Biocorp. You are employee of Embassy. You are employee of Tata Motors. You will be named as inventor, but the owner will be the respective organization. There's a well accepted international principle is called work for hire. You have been hired to do research work, and your research will be owned by a person who hires you. So very often, there are non-employees who get hired for certain ad hoc work. You have a new building, you hire an artist to make a mural. You have an architect who does a drawings of building. You get Infosys to develop ERP for your institute. You hire McKinsey to do an organization study. In all such cases, the respective service provider is the owner, unless by a prior agreement you say, in lieu of the compensation which we are paying you, we will own it. Then only you are the owner. Very often we go to the government agencies for the grants, sponsorships. If you read the fine print, they clearly say this work will be assigned to Department of Biotechnology, Department of Science and Technology, or to the CSIR. In US, it is called marching rights or shop rights. Government has a royalty-free license to use that work in the public interest. So they can anytime march in and exercise that right. Now, when we talk about the patents, there are different type of patents. But whenever we talk of the patents, it's called utility patent. We don't have to specify utility patent. It is understood that we are talking about utility patents. Other than that, there are different type of patents. US gives design patents. Worldwide, you get a design registration, but the US is the only country which grants a design patent with a 14-year life. US gives plant patents, that is asexually produced plants or tubers, etc. Then the innovation patents. See, patenting system is time consuming, expensive. So a lot of small and medium enterprises done marginal improvements. So country like Australia have a concept of innovation patents for such marginal improvements. So these patents have a life of 7 to 10 years, not very critically examined. Examination takes place if only there is a litigation or representation. There's another word for this, which is called utility models. Now don't confuse utility models, utility patents. Concept different. All this we keep on hearing China has a large number of patents. Those are all utility models. So fall in that innovation patent category. Then there's a concept of provisional patents. What is a provisional patent? You are doing research, work is not complete. Now you have more work to be required. I develop something, I want to do testing. I don't have a testing facility. IIT Bombay has a testing facility. I go to IIT Bombay, but I'm afraid. There are other students, there are other faculty members, my invention will be exposed. Somebody may steal the idea, somebody may go and file the patent. And developing a product, I want certain parts. I have to talk to a vendor. I must share the drawings with the vendor, explain to him what I want, why I want. I'm afraid. He may steal, he may go and give it away to somebody. So in such cases, provision exists. I file an application which is called a provisional application. So my protection starts the day I file the provisional application. But there's a requirement. Within 1 year, you must complete your invention and file a full application. Then only that protection remains. Now what it does is, it temporarily protects you so that anybody who files after you will not get a protection. But in 12 months, you must finish. After 12 months, if you don't do it, you lose that priority of a provisional application of 1 year. You will start afresh. Then there's a provision of compulsory licensing. Patenting system does create monopolies, and those monopolies can be exploited at the detriment of the society. Imagine, let us say today no country is left free of the COVID, but let us say you can say a cholera. Merck has a cholera vaccine. Germany doesn't have cholera, so Merck is not producing it. Now we have cholera outbreak, and we don't have vaccine. We go to the Merck. Merck says, I'm not interested in licensing. Or Merck says, keep a $1 billion on a table, then we'll give you a license. It's very unreasonable terms. You get to government of India and saying, here's a Merck patent, and they are being unreasonable, they don't want a license. Government can grant you a compulsory license, saying, go ahead and practice that invention and just pay 2% royalty to Merck. In the public interest, that provision is exercised, and we have done it number of times. So that is a safety wall for if somebody wants to exploit and take the society for a ride, government granted license. I told you it's a territorial right, only restricted to grant given country. There is no concept of world patent or international patents. You need to protect yourself in every country, in other countries, if you want your invention and markets to be protected. So there are no international patent or world patent exists. But what does exist is an international patent filing system. Because what happens, I file in India, it takes me 3 months to file in US, 6 months in Germany, in Japan. I have to translate every document into Japanese language. Now what happens in the meanwhile if somebody files there? It creates complications. So they have reached an agreement which is called Patent Cooperation Treaty, under which you can have single filing system. In a sense, you put up an PCT application that becomes your priority date for across the world. You file a PCT application today, then the international search is done and publication is done after 18 months. And after that, you have 12 months to file wherever you want to file in the world. Irrespective of when you file in those 12 months, your priority date remains the same of your first date of PCT application. So this simplifies the process, simple priority date. You get a time to take a decision, which is the biggest advantage. 18 plus 12, 13 months you get to perfect your invention, test market your invention, talk to people if they want to take a license, etc. And plus, WIPO publishes this, WIPO deals with it. So effectively disseminate technical knowledge worldwide. And there are certain patent offices, especially in the developing world like Africa, Middle East, etc., they do not have technical capability. So they depend on these reports. So increase their patent offices. I told you it is a grant giving country only, but the Europe has a European Parliament, the European Patent Convention. So there's a system of European patent, which is valid in all the member countries. And this is independent of their national system like German, French, Netherlands system. So you can get a European patent applicable in all European countries. Looking at this, Africa, Middle East want to follow the similar practice. There's an oldest convention on IP, it's called Paris Convention. It was formed in 1883. We were not the members till the first Vajpayee government came because we were not granting product patents, so we were not members. But now, since we introduced the product patent, we are a member. There are three important parts to that. One is, irrespective of the PCT system, if your country is a member of the Paris Convention, you can file anywhere else in the world within 1 year with the same priority date. Suppose I file in India today, within 1 year I can file in any of the member countries, but I'll get the same priority date of 10th March. There's a concept of national treatment. Everybody is supposed to treat the inventor of other country the way they will treat their own national. So in India, there cannot be a Tatkal system for Indian inventor. Indian inventor and American inventors will be treated equally. Same thing when you go and file in US Patent Office, the US inventor and Indian inventor will be treated equally. Third thing, independence of patent. Invention may remain the same. Just because US has been granted patent, automatically India will not grant you the patent. US will grant you a patent for the second use of a drug compound. India will not. So you cannot come and say US has granted me patent, so India also should grant. India will grant a patent as per their law. Invention is same, but you may get a patent in US, but may not get it in India. Now what does happen once you file a patent? Once patent is filed in the patent office, they look whether you have met the procedural requirement or not. Then patent office is organized on the discipline based. So life sciences, chemical science, engineering, other engineering, different branches and so on. Depending upon the maturity of patent office, the specialization goes. I met a bunch of German patent examiners, 8 of them. Their only specialization is IC engine, nothing else. They're not mechanical engineers. Means they are not classified as mechanical. They are specialists in internal combustion engine. That is the level of specialization German patent office has. So in our case, it is still 4 groups: chemical, life sciences, mechanical engineering, electrical engineering. Electrical engineering has everything: electronics, telecommunication, computer, etc. So patent will go to one of those examiners who will search the prior art, research article databases, Scopus, etc., patent databases, Google, and all that. And he'll find out is there a prior art, and he will cite that prior art to you. Seeing in the light of this prior art, your claims are rejected, which is very normal. He will also give you grounds why he is rejecting that. You are supposed to study all those references, go back to him and explain to him how, in the light of prior art, which you said your invention is different, and give him explanation. He may go again do a search and come back with another prior art. And this process goes on till you convince him that you have a case. And you are allowed to amend your claims because probably you are not seeing certain prior art, so you may like to restrict your claims. You might to withdraw your claim. This goes on till finally agreement is reached that yes, you have a case and patent is granted, or you don't have a case and it's completely rejected. And then publication is done, then people can object to it, is left public, and this is how the process goes. Now let's look at important milestones. Our patent law came in 1856, which was based on the British Patent Law 1852. And because we are a UK colony, they changed their patent law at the end of the century. What they had a Ray Commission. So we had a new law in 1911. And this is where the concept of product patent and composition patent became available. Then I told you in 70s, we changed that law. Only process patents in pharma, agro and food. And term was 5 years from date of grant, received and date of application. In 94, we signed a GATT agreement under which patent laws were to be harmonized across the world. We were given 10 years time. 97, we became member state of PCT. And the law which we were supposed to change in 10 years, we changed in 3 installments, 99, 2000, and 2005. So 2005 saw the reintroduction of product patents for pharma, food, and agrochemicals, and patents for other technology areas like biotech. So today our IPR laws are TRIPS compliant, so we meet all those international obligations. So coming to my final slide about commercial exploitation of patents. Patents to exclude the competition. The pharma industry does it beautifully well. It's a shining example of that system. Patents for survival. In the biotech industry, a lot of tools, techniques were patented, including your PCR was a subject matter of patents. You couldn't use PCR till you get a license. So if you bought a PCR machine, the machine manufacturer had taken a license from the original inventors, and you were granted a license because you printed that machine. And the price of the machine had the licensing fee included. Now PCR is gone off the patents, but in biotech, there are many of such patents. So for survival, to do that, you require them. In the electronic industry, people infringe each other at the periphery. So what they do? They cross-license, use their patents as bargaining chips. I have this patent, I can sue you, but the other fellow also has a patent, he can sue me. So we say, okay, let us cross-license. Universities, I gave you an example of Stanford University, so it was a source of royalty income to them. My personal example being an NCL, for us it acts as a marketing tool. See, we are a research organization, we are not business organization. Business organizations have business strategy. They have technology strategy, and they have IP strategy to back that technology strategy. No, we are not a business. All our research is driven by the science. So scientists perceive that they can solve this problem. So we do some inventions, we take a patent. We don't know the real life problems. The moment you publish your patents, there are people who monitor, particularly industry. They see a patent, they see certain technology. They know the underlying skills can solve that problem. You might have solved some other problem, but there's an underlying skill you have. So we are approached by people saying, look, we have a problem, and you have technology, and that technology can solve this problem. So we have taken contract research to do that work. We may or may not have licensed the patent, but that patent was like putting the flag there, act as a kind of marketing tool for us. And then if you're an individual inventor, it's very difficult because what happens unless you have breakthrough patent, an invention cannot be just protected by a single patent. You require a bunch of patents, a portfolio. Otherwise, people who start inventing around will do derivative work or will do analogous work. But if you have a breakthrough, then it's a kind of lottery ticket for you. With this, I'll stop and open for the questions.
Now, sir, now you're with your permission, shall we proceed ahead with the question answer session?
Yeah, please go ahead.
Sir, we have received few questions.
Yes.
So I would like to request all the participants to post their question on the chat box. The first question is, sir, if any novel procedure for the preparation of any product and that procedure one has published in the research paper, after publishing, can we file patent for the same?
No, you cannot. You already have made a public disclosure. Now the novelty gets destroyed. No longer is novelty. It says it should not be part of prior art. The publishing a paper you have made is a part of prior art.
Okay,
As
sir.
I told you, only US will give you that grace. Within 1 year, you can file in US, nowhere else in the world.
Okay, sir. So our next question is, sir, why patents granted in India are less compared to other countries?
See, one is we spend very less on research and development. Second, a lot of people who do inventions are wary of our judicial system and enforcement system because our courts take very long time. Our courts are taking 20 years to decide the cases. Our enforcement machinery is weak. So people feel they will not derive that benefit. If somebody infringes, to go to the police, take the action, go to the court. Patent has a limited life. If your courts are taking that much time, so they think that they'll not derive benefit. So they find other methods to maintain trade secrets and those kind of things to protect.
Okay, sir. So my next question is, sir, how one can learn about how to draft the write-up related his or her products during process of patent filing?
If you ask me honestly, I don't recommend researchers to write their own patents because what is a patent? It is a document which you can go, gives you right, which will go and enforce in the court of the law. Now you do not know how court interprets the document. You are a scientist. You know how to do an invention. You are not a lawyer. You don't read judgments. See, when you read those judgments, then you see how the court interprets. And very often, court specifies in the landmark cases the test which should be applied. You were not in that profession, so don't you keep on reading it. You are not aware of those tests. You are not aware of that language, so you'll end up writing a paper. So leave it to the people who are best trained and practitioner to do it. You write what is called an invention disclosure. The smart people who write this will ask you a right kind of question and will draft it. So leave the job to a professional.
Okay, sir.
Although there are courses of WIPO and patent drafting, there are books on that, you can read them. But my advice is not to do it yourself because you will not have a patent has to be litigation ready. So you will not make a litigation ready document. You will make a publication ready document.
Okay, sir. So the next question is, where to file the patent application and how much does it cost to file for a patent?
See, we have 4 patent offices: Bombay, Delhi, Calcutta, and Chennai. But what has happened? So your respective jurisdiction you are supposed to file. If you are in Western region, you'll go and file in Bombay. But now patent filing is online, so it doesn't matter where are you situated. Online, you can file it from anywhere. Patent filing costs vary. What is your status? Are you an individual? Are you a small enterprise? Are you a big company? So cost varies. But if you ask me, right from filing, prosecution, maintaining, you end up spending about 1 lakh of rupees total life cycle of a patent. As is filing will cost few thousand, but then there are later on subsequent expenses.
Okay, sir.
Hello, sir. Can I ask you a question?
Yeah, please.
So specifically in our laboratories, in our third year's projects, so specifically students do some of the experimental based, you can say, projects, which they have to carry out for their university. So my question is with respect to this is that if a particular student is performing an experiment and
Yes.
in that experiment which is a standard protocol, so if the student happens to modify a protocol with respect to the standard, so that can that modified protocol be patented or not?
But he must satisfy where modified protocol must pass the patentability requirements, which I told you. Novelty, non-obviousness. If it passes that test, yes, it can be patented.
Okay,
So
sir. Okay, sir. Thank
every case you have to see in that context and in the context of the prior art which exists. See, you may have modified, but have you looked at the prior art? See, in the
Okay,
academic
okay.
institution, they don't teach us to see as a patent. They ask us to look at papers. 70% of new knowledge is in patents. An academic institution, we don't look at the 70% of new knowledge. So while you're doing literature survey, also do a patent survey. All patent databases are worldwide available freely. It's called eSpaceNet, which is a global patent database. Only when you see nobody has patented it also, then only you think of patent. Just don't read papers and think you've done something new.
Thank you, sir, for answering questions of our participants. Now, I would like to request Dr. Paramjit Anthapan ma'am to thank on behalf of IWSA. Anthapan ma'am.
For giving me this opportunity to express a few words on behalf of IFSA. It was indeed a very, very wonderful lecture, and to have such a resource person who has actually pioneered the patent analytic services in India. I think all of us are indeed very fortunate and very lucky to hear it all from Dr. Raj Hirawani. I must say, Eureka. In fact, perhaps many of you must watch the YouTube interview, which Dr. Raj Hirwani has given on Eureka, which is the Rajya Sabha TV, very, very lucidly and explained very simply with such, ease. It's really interesting to know because now is the age of patents and copyrights, and all of us really need to be aware, looking at the current scenario of the country, the opportunities for students that exist in the Better India movement. And like when perhaps in our time, whenever we took, I still recollect when we took lectures for the postgraduate students, we used to make a statement: research cannot exist in a vacuum. Research cannot exist in a vacuum. Yes, that was the thing. And perhaps the things were, you either publish or you perish. These were some of the notions that we have always been highlighting. Looking at Edison's story itself, in fact, if you look at it from the point of view of research cannot exist in a vacuum, the moral responsibility of every scientist and researcher to actually publish his work, whether it is positive or negative result, both are results. And I think the same person, the same scientist, he's well known for publishing 10,000 different ways in which things did not work. So that also becomes a great encouragement. So, and look at the other side, we talk about chance favoring the prepared mind. Today's lecture was indeed such a beautifully woven, lucid, scientific story of every point abstracted and circulated in the lecture before the statement. So, I mean, it was really wonderful to hear, mesmerizing, very good. And I would say the take-home message that is really important is, we thought publish or perish. Today, perhaps patent not to perish, but to progress society and to facilitate the progression of society. So I think this is a message that we can all take forward. And another very important thing, that to young researchers, our postgraduate students, when one does a literature survey, which is a very integral part of, before you actually start doing when you are conceptualizing and when you're, filing a proposal, submitting to the university, also do a patent search. I think this is a very important statement which survey, which we all should really look into. Okay, so wish you all the best and wonderful lecture. I'm sure. Thank you on behalf of IBSA, the all the arrangements that were made on behalf of the college for this great lecture. So wish you all the best. Stay blessed always. Thank you.
Thank
Thank
you,
you,
ma'am.
Professor Param, for those kind words.
Pleasure. Pleasure.
So before we end the session, the feedback link will be posted in the chat box and the participants are requested to fill up the feedback form. As we end the session, I would like to thank Dr. Mala Khatter, the CEO, and Dr. Shrikant Sawant, Principal of Patkar-Varde College, for their support. I also thank Mrs. Ruchita Darvi and Mrs. Anupama Tomar, Mrs. Neha Kolako, as well as Dr. Anthapan ma'am, Dr. Surekha ma'am, and my colleagues for their constant support. I wholeheartedly thank to Dr. Raj Hirawani sir for enlightening us with the fundamentals of patents and the steps to the frame objectives, as well as taking out time from the busy schedule. Lastly, a big thank you to all participants for participating in this session. Thank you. Stay safe, stay healthy. Thank you so much.